So in this video, we're going to take a look at our next trigonometric equation, which is called cosine. But before that, before watching this video, you want to make sure that you're good with sine. And you should be able to answer these three questions here. So what is sine? What if you had to explain to someone what sine was? Well, you might say something like this. Sine is the observation that an angle has a constant opposite over hypotenuse fraction. All that means is that the opposite side divided by the hypotenuse side of an angle such as, 20 will always equal 0.342. So no matter how big the triangle is or how small your triangle is, as long as you're focusing on an angle of 20 degrees, your opposite divided by your hypotenuse will equal 0.342. Another way of saying that is that the opposite will always equal 34.2% of the hypotenuse, because that's how you can interpret fractions as percentages. So that's really the essence of what sine is. Now for number 2. Which will produce a bigger number, sine of 12 or sine of 85? And the answer to that is sine of 85. Remember, sine is just the opposite divided by the hypotenuse of some angle. Look at how big this opposite side is when compared to the hypotenuse side. The sine of 85 is 0.996, and that should make sense. Look how big that opposite. It's 99.6% as long as the hypotenuse. And the sine of 12.208. So for a 12-degree angle, its opposite side is only 20.8% of the hypotenuse side, and that should make sense. Look how small this opposite is, and look how big the hypotenuse is. So it should make sense to you why small angles, like 12, have small sine fractions. Big angles will have big sine fractions. And lastly, why is the sine of an angle always less than 1? Well, remember, the sine of some angle really is just that opposite over hypotenuse fraction for that angle. And remember, the hypotenuse will always be the longest side of a right triangle, which means the denominator will always be bigger than the numerator, which means this number as a whole must always be less than 1. It can never be greater than 1. So make sure you're really getting this stuff before watching this video, because in this video we're just going to tack on a little extra stuff. It's going to feel very similar to the sine video, and I'm going to go a little more quickly because it's so similar. So in our last video, the sine video, we started out with the observation that an angle sort of creates the side opposite here. And a big angle will create a big opposite side, and a small angle, like this one over here, will create a much smaller opposite side. So time to bring our friend Pythagoras back in. He was thinking that, you know what, I'm noticing that not only does there seem to be a link between our angle and our opposite side, but there seems to also be a link between our angle and our adjacent side. When our angle is big, our adjacent side is small. But when our angle is small, like over here, our adjacent side is big. So although it's not as easy to tell as it was with the angle and the opposite side, but in a sense, the angle produces the adjacent side as well. The bigger the angle is, the smaller the adjacent side is, and the smaller the angle is, the bigger the adjacent side is. So Pythagoras was thinking, wow, this feels just like my sine adventure felt. You know what? There's probably a pattern, just like there was for sine, but now for the adjacent over the hypotenuse, rather than the opposite over the hypotenuse. And Pythagoras turned out to be right. after doing experiments, just like we did in the last video, he did those same experiments, but he measured the adjacent divided by hypotenuse fractions. And he came up with this conclusion. So for a 10-degree angle, the adjacent divided by the hypotenuse will always equal 0.985, regardless of how big, how small the triangle is, or whatever. This is just like sine, but this is an adjacent divided by hypotenuse constant fraction instead of an opposite over hypotenuse constant fraction. So for the 10-degree angle, the adjacent will always be 98.5% of the hypotenuse. And for the 75-degree angle, the adjacent divided by the hypotenuse will always equal 0.259. So it should make sense why small angles will have big adjacent divided by hypotenuse fractions, because look how big these adjacents are. But big angles will have small fractions. So of course, Pythagoras knew that every angle had to have its own adjacent divided by hypotenuse fraction. And Pythagoras did these same experiments for all the different angles to figure out each of their adjacent divided by hypotenuse fractions. And soon enough, he had a list. So here's the sine list for comparison. And it should make sense that our new adjacent over hypotenuse concept is in a sense the opposite of the sine concept. The sine fraction for small angles is small, while the adjacent over hypotenuse of small angles is big. And as your angles get bigger, your sine fraction gets bigger, while the adjacent over the hypotenuse fractions get smaller. And just like sine, adjacent over hypotenuse will never be bigger than 1, because the hypotenuse is the longest side of a right triangle. The adjacent side will never be greater than it. So this new adjacent divided by hypotenuse phenomenon that Pythagoras had discovered was kind of like sine. It was kind of like sine's partner. You might even say it complemented sine nicely. When sine was small, adjacent over hypotenuse was big, but when sine was big, adjacent over hypotenuse was small. So because of this, Pythagoras named this new thing cosine. And he rewrote his entire list. And just like sine, this entire cosine list is in your calculator. You can calculate the cosine fraction of any angle that you want. So now we're ready to do a practice problem. Alright, so let's solve for this unknown side. Step 1, of course, is always naming your sides. So we can use cosine to solve this, because cosine just means adjacent over hypotenuse, and we know the adjacent. So I'm going to use the cosine of 30 degrees, which my calculator says is 0.866. And I know that all this new concept cosine means is the adjacent side divided by the hypotenuse side, which we know for a 30-degree angle will produce 0.866. We know that the adjacent side is 4, and the hypotenuse is unknown. So if I do my algebra and do 4 divided by 0.866, I will get 4.62. And there we go. We've used cosine. Now let's say the question asks for the length of this side here. Now we could use the same technique that we did in the practice problem of the last video, which involved us switching our angle of focus here. So we could do that. We could switch our angle of focus to this one, which would rename the sides of the triangle, and then we could basically use cosine again. This would be cosine of 60. But we could actually use sine. We could actually keep our angle of focus as our 30 here and use sine to answer this question. So the sine of 30 degrees is just 0.5, and I know that sine just means the opposite side of that 30 divided by the hypotenuse side. Opposite is unknown. Hypotenuse we now know to be 4.62. 4.62 times 0.5 2.31. So we have solved the triangle without even having to figure out that angle like we had to do in the last video. So we have sine, now we have cosine, and in the next video we'll look at the last trigonometric equation.